Okay, repeat prefixes. So we have looked at the prefix we've used when we had a move instruction that differed only in the size of the operands, or registers in our case. So these two instructions would have had the same opcode, and we would use a prefix byte to indicate something other than the default 32-bit operand size. So that's the first time we saw prefix bytes. We're going to see prefix bytes for some repeat prefixes that allow these string operations to repeat automatically, either for a fixed number of iterations of a loop or until some condition is satisfied. So since these are prefixes, they will actually not be mnemonics for an instruction or an opcode. They're just repeat prefixes, and there are actually just two of them, and I'll show you what they look like. They're not themselves instructions, but they supplement machine codes for the primitive string instructions, making them in essence a new instruction. Okay, so the first one, and you know what, maybe I'll go back and tell you a little bit about these repeat prefixes just real quick. So I've got repeat, which is going to repeat while ECX is greater than 0. I've got repeat if equal, repeat if 0, which will, again, while ECX is 0, will actually begin execution of the atomic instruction, but then at the end we'll look at the 0 flag to see if that extra condition is satisfied. Then, as you might expect, repeat not equal, repeat not 0, ECX. It'll check ECX 0 before, and then after the instruction has been executed, in this case, we'll check and see if the 0 flag has been cleared. So those are the repeat prefixes that we're going to be looking at. Those, I've got two for the equal and not equal, just again to make code easier to read, see what makes more sense. All right, the repeat prefix itself is normally used with move s and store s. Kind of makes sense. Move and store are just doing themselves a move. Move doesn't affect the E flags, so I don't need anything that's going to be modifying the 0 flag in our case. But the repeat prefix itself, the singular one, will cause the following design to execute. So while ECX is greater than 0, I want to execute my primitive instruction, and I want to decrement ECX by 1. So that's what the repeat prefix itself is going to do. Now, this algorithm is really important because it's going to test this first before it ever executes the primitive instruction. That means I don't have to have a loop guard necessarily if I know that that's always going to be the case, and it is with the repeat prefixes. So that's the nice thing about the repeat prefix. Additional repeat prefixes, I've got, again, repeat if equal, same as repeat if 0. And repeat if not equal is equivalent to not 0. These are appropriate for use with compare string and scan string, since both of these are going to be doing comparisons and evaluating whether or not something is equal. So it's appropriate in the case of either of these repeat prefixes that we might want to use them in conjunction with compare or scan. All right, so let's look a little bit more at the detail. These repeat if equal, not equal, zero, not zero, work similarly to the repeat prefix, iterating primitive instruction while x is greater than 0. But they each also examine the 0 flag after the string instruction is executed. Okay, so as we mentioned at the beginning, repeat equal or repeat 0 would continue iterating while the 0 flag is set, as it would be following a comparison where two operands were equal, and then conversely repeat not equal, repeat not 0 would continue while the 0 flag was cleared. Compare string. All right. With compare string, we are going to do very similar to the compare instruction. We're subtracting two strings, and that subtraction will set E flags. So, as you might surmise, this makes sense that we would use these in conjunction with one of the conditional jumps. As is the case for the normal compare, neither source nor destination is changed. And again, it is appropriate to use conditional jumps after a loop. If I use it in a loop, it's appropriate to follow with compare string with jump if equal, jump if not equal, some conditional jump instruction. But I could use this also and get rid of the loop structure if it's possible and just use one of the repeat prefixes. So in this case I would say repeat while equal compare string and some size. Okay. Scan string. Scan string is used to scan a string for the presence or absence of a particular string element. So the address of the element being examined is in EDI. This one, that's important to remember because it's easy sometimes to forget which one of these is looking at EDI, which is looking at ESI. The element being scanned for is in the accumulator. Okay, so again,